Okay, this multiple choice asks for the interval of convergence for this infinite series. Okay, now it's not a geometric because of this n here, so we have to use the ratio test. And in general, you can always use the ratio test to find interval of convergence when you're taking the AP exam at least. Okay, so we're going to do the ratio test. Okay, and so the ratio test has us analyze the limit of the ratios. Okay, so we need to see what this equals. Okay, so recall, all right, so this is a sub n, this expression. Okay, so this equals, so before, rather than analyze the limit directly, let's just get an expression down for this, right? So what is this? This is, okay, so it's the n, and again, it's, we're going to change it so it's not looking so much like a fraction here, but this will be the, if you're going to be literal, you'd write this. I'm gonna change it just this once. I think I'll write it like this, but you know, big fraction. So it's the absolute value of the n plus first term, which would be this. Okay, and then the nth term is just what you're looking at in the infinite series there. Now, like, you've got this is a compound fraction of two things. It's a compound fraction, so it's a fraction within a fraction. And the other thing is, like, the absolute value bars are allowed to just hug the x plus 4 expressions because those are the only things at risk of not being positive. Because n, 4 to the n, those are going to be positive because n's going from 1 to infinity. So those don't need to be have absolute values around them. In any case, typically we write this like this instead. So, you know, dividing by that fraction means multiplying by its reciprocal. So this is typically what we would write. In fact, we probably want to write this instantly. This one video, I think I'll be like really thorough. Okay, but multiply by this, which is the reciprocal. Okay, and we do some canceling where we can. So this will leave a 4, and this will leave a copy of an absolute value of x plus 4. And be careful, the n over n plus 1 doesn't cancel. It will kind of vanish when we take a limit, but it doesn't cancel. So here's what I'm left with. Again, remember, this is all an expression for that. This is going to give us so I have an absolute value of x plus 4 times an n on the top, and then down below, all I have left is a 4 and an n plus 1. Okay, and so when you take the limit, because remember, we are taking the limit, we get, okay, the limit as n goes to infinity of this expression. Okay, anything that doesn't involve an n can be taken out of the limit. So like that and that I usually take outside. Okay, so I'll get absolute value of x plus 4 over 4 times the limit as n goes to infinity of n over n plus 1. Oops, n over n plus 1. And then you want to recognize using your knowledge of limits that this, okay, is equal to 1. So this ratio in the end, the limit of the ratios is this. Okay, and by the ratio test to converge, we want, okay, this to be less than 1, which implies this is less than 4, which implies this, oops, minusing 4 tells us that this is our interval of convergence. Sorry, this is the beginning of our interval of convergence so far. So we still have to analyze the endpoints. Let's go look at what we can cross off. Obviously, we can cross those off. The only thing we got to check now is we got to see if -8, look at the difference between C and D. The question is, so the ratio test doesn't tell us what happens at these endpoints, so we got to check them. So we only need to check -8 because that's the only difference between, that's the only difference between this answer choice, C and D. So we're going to plug in -8. So when x is -8, we get -8 plus 4 to the n. Okay, so our series becomes, what's it starting at again? 1 to infinity. Okay, so -8 plus 4 to the n over n times 4 to the n. Just double checking, yeah. Okay, and so what does this become? So this is -4 to the n over n times 4 to the n. And there's a division that can happen here. Okay, to be real thorough, this is what you can say. Some good algebra technique here. This is -1 to the n times 4 to the n. Again, because this is like -1 times 4 to the n. Okay, so then I get a cancellation, and I'm left with this, and then this should just be recognized. So it's okay if you get to what I'm writing down quick. I'm just trying to be thorough here. This you should recognize as something that converges conditionally. Okay, I'm not going to show that. Hopefully you come to this maybe recognizing that it converges conditionally, so that tells us we need to do this. So there's our integral convergence. And we don't need to check 0 because it's multiple choice, and that must be the answer.